Hey everyone, and welcome to this explainer. Today, we're tackling a massive question, sitting right at the intersection of engineering, AI, and sustainability. What actually is a digital twin?
So you've definitely heard this buzzword thrown around, right? Whether it's in boardrooms, tech articles, or even science fiction. It sounds incredibly futuristic. But is it just a fancy 3D avatar? Like a high-definition model you can just spin around on your computer screen? Or is it something much, much more powerful? To really grasp this, we need to clear up a super common misconception right out of the gate.
Here is the absolute crucial point. Honestly, if you take away just one thing from this explainer today, let it be this. A virtual clone without a live data stream from the physical world is just an avatar. It is not a true digital twin. A static digital clone is purely visual. Sure, it might look exactly like a real-world jet engine or a massive skyscraper, but it's basically just a 3D photograph. A true digital twin, on the other hand, is alive. It's a dynamic, precise emulation that relies entirely on a continuous, real-time data stream from its physical counterpart.
Now, strictly speaking, a digital twin is defined as a digital representation of a physical asset utilizing a real-time exchange of live data between the digital and physical components. And honestly, it's that second half of the sentence where the magic really happens. The missing ingredient in your standard run-of-the-mill simulation is that continuous feedback loop. When the physical object experiences a sudden drop in temperature, the digital twin feels it instantly. When the real-world object experiences stress, the twin registers it. They are fundamentally, inextricably linked together. You know, while today's technology feels like magic, the core concept actually traces back decades. Think back to 1970. NASA engineers on Earth used physical hardware twins to safely bring the Apollo 13 astronauts back home. They used identical physical models of the spacecraft down here to test solutions before instructing the astronauts up in space. Today, while we've replaced those physical models with advanced IoT, AI, and cloud-powered digital emulations, and looking to the future, this technology is literally the foundation for a digitally empowered circular economy, which we're going to dive into in just a bit.
The engine of the twin, the live data loop. So how exactly does a digital file on a screen know what is happening to a piece of metal thousands of miles away? Well, Internet of Things, or IoT sensors, act as the sensory organs for the physical asset. Out in the real world, these sensors capture live data. We're talking acceleration, tilt, extreme temperatures, humidity, chemical levels, even acoustic vibrations. They constantly feed this environmental data back to the digital replica. You're basically giving a digital file a central nervous system. Pretty wild, right?
But gathering all that data, that's really only step one. For a digital twin to actually be useful, it relies on a whole intricate cocktail of technologies. It uses IoT to gather the data, cyber-physical systems to build the actual bridge between the physical and digital realms, and of course artificial intelligence alongside advanced analytics to make sense of the whole shebang. AI is the heavy lifter here. It processes that massive wave of field data into actionable feedback, allowing systems to actually predict failures before they ever happen in the real world.
The ultimate test drive, Dallara Automobili. Theory is great and all, but let's take this for a spin in the real world with Dallara Automobili, an Italian high-performance and Formula One car manufacturer.
In the world of competitive racing, fractions of a second matter, and innovation needs to happen at lightning speed. It's absolutely fascinating to think about a physical race car undergoing complex aerodynamic testing right alongside its digital twin. Before a single piece of expensive carbon fiber is even cut, Dallara creates a digital twin of the car's engine and its aerodynamic components. Their engineers can test modifications, monitor performance, and study airflow in a totally safe virtual sandbox that perfectly emulates the real-world physics of a racetrack.
Think about how revolutionary this is conceptually. Historically, physical prototyping meant building actual cars just to compare them against each other. That wastes massive amounts of energy, tons of raw materials, and months of time. Digital twin testing, however, that means zero physical waste, rapid deployment, and the ability to test literally infinite combinations. Dallara monitors performance and optimizes everything digitally before manufacturing a single part. That is a massive competitive advantage.
Transforming global industries. Because if we can safely optimize a high-speed race car to this degree of precision, the scale of applications for other complex global industries is just awe-inspiring.
Take the energy sector, for example. We can now monitor offshore wind turbines using digital twins. These are massive assets located in incredibly harsh, remote ocean conditions where a storm could be devastating. Instead of sending a human crew out in dangerous weather to inspect a turbine, the digital twin runs predictive and preventive maintenance. It constantly analyzes stress levels and weather data to predict a breakdown before it even happens. That saves time, huge amounts of money, and potentially even human lives.
Or what if we scale it up even further to replicate entire manufacturing plants? Imagine a smart factory rendered as a fully interactive digital twin. Plant managers can simulate major process changes, completely reconfigure assembly lines, or test brand new machinery in the digital space without ever needing to shut down the actual physical production line. They completely de-risk the changes by proving them virtually first.
In aeronautics, the stakes are quite literally sky high. Airplane engines are augmented with live sensor data and wireframes, allowing engineers to use identically rendered dynamic dimensions to safely test incredibly risky modifications. They can push an engine to its breaking point virtually, without putting human lives or multi-million-dollar materials on the line. This drastically improves aircraft design while ensuring the ultimate safety for passengers.
And honestly, if you think that's incredible, the technology is expanding beyond just steel and machines straight into the biological realm. We are beginning to map the human body, paving the way for digital twins in medical research. Just imagine simulating a complex medical treatment or predicting how a specific patient's internal organs will react to a brand new medication, all on a digital clone driven by their unique vital data before ever administering a single drop of the drug in real life. The potential to save lives here is absolutely staggering.
The big picture, a sustainable future. Let's zoom out for a second to see why this matters so much for the overall future of our planet. Digital twins aren't just a cool operational tool for engineers, they are becoming a fundamental pillar for global sustainability. The strategic and environmental benefits are undeniable. By moving our trial and error out of the physical world and entirely into the digital realm, we drastically reduce physical material consumption. We significantly lower emissions and pollution because, well, we aren't constantly manufacturing and discarding failed prototypes. Most importantly, it enables a truly circular economy. When you can digitally test how an asset behaves over its entire life cycle, you can design it from day one to be easily disassembled, refurbished, and recycled. It really all boils down to this. Digital twins allow us to study and test much wider possibilities and innovative approaches safely in the digital world. Utilizing live data to build virtual twins gives us the ultimate competitive advantage. It lets us push boundaries and innovate without that paralyzing fear of a catastrophic physical failure.
Which leaves us with this final thought to ponder today. As digital twins continue to evolve, blending IoT, AI, and live real-time data, if physical risk is completely removed from the equation and we can safely test absolutely anything in the digital world, what incredible things will we be brave enough to build next in the real one? Thank you so much for joining me for this explainer. Keep questioning, keep learning, and I'll see you next time.